Hi, I'm Jonathan Berger. This talk is called Towards a Theory and Methodology of Test-Driven Design, which is a little bit of a mouthful, but it's something that I've been very excited about and very interested in for a long time. Actually, tried to give this talk about a year ago, and I didn't have it all together, and I started with this same slide, and the next slide struck out all that stuff and said, no, we're not giving that talk this time. So now we're giving this talk, and I'm very excited about it. I'm Jonathan P. Berger. You can find me everywhere on the internet at Jonathan P. Berger. I kind of started life as a designer and went on to do quite a bit of coding and PMing as well. I was working for the last 7 years. I recently left, but for the last 7 years with a Agile design company and development company called Pivotal Labs. How many people are familiar with Pivotal? Okay, so that's most of the room. So you guys know it's a test-driven XP shop, and over the course of that time as a consultant, I got to work on a lot of projects, which was really cool, because I got to see a lot of different teams and a lot of different problems, a lot of different sectors, and it became a very interesting way of abstracting away what is this app versus what is it to build apps, and I hope I can share some of those learnings with you guys today. So along that time and along those 30-odd different projects, the one thing that was constant the whole time was an interest in and a love for Agile, and particularly what does Agile look like for design? Agile's always been an engineering discipline and a set of techniques, and we'll talk about this in a little bit, a set of techniques that was built by and for engineers, but designers have a lot to benefit from Agile, as well as needing to work with it sometimes. So the more we can do to advance Agile design, I think the happier we're going to be as designers and as teams. So just before we get started, I want to get kind of a read of the room. So nobody is a developer. You practice development. No one is a designer. You practice design. But how many of you would call yourselves designer? That's your job title. Okay, that's maybe like I don't know, quarter, 20% of the room. What about developer? Okay, that's pretty much the entire rest of the room. Did I miss anything? Anybody else? Shout it out. What do you guys do? PMs. Okay, so project management. Cool. But mostly developers. And how many of the developers in the room, how many are familiar with XP and TDD and pairing and all that stuff? Okay, that's at least half, maybe 60% of the room, so I might speed through those things a little bit. I'm not going to read this whole thing, but the kind of idea here, as I alluded to earlier, is that we want to take Agile techniques and we want to see how we can apply them to design. And in particular, in this talk, I want to address testing and address what does it look like to do automated testing, to do test driving in the design context. So I'm a good lean person, and I set up hypotheses around what I'm going to do. So hopefully this derives acceptance criteria, and we can decide whether or not I achieved what we started out with, right? First of all, I'm going to assert that design can learn from Agile development. Second of all, it's not exactly one-to-one, right? We don't have sophisticated version control. We don't have, for the most part, an answer to ping-pong pairing, where we can take our TDD and we can take our pair practice and make them work in a nice, sustainable manner. And finally, I'll suggest that as people are talking about testing, automated testing, test driving in design, and we're starting to see some tools emerge, tools like Wraith and Hardy and CSS Lint, as we see these things happen, what we're starting to see is that there is a little bit of tooling, but not a lot of theory, and not a lot of a story that we can start to tell ourselves and each other about what does it look like when this works? Where are we going to? And with development, I could tell you a story about, well, we've got CI, we've got tests, and this is why it makes our life better, and this is how the unit tests talk to the integration tests, talk to the acceptance tests. But what I'm hoping to do in the course of this conversation, both in this talk and subsequently, is to start driving out that story for design. Okay, so we're going to break that down into talking a little bit about testing and what it means in these contexts. We'll jump into some theory, into some methodology, and then we'll try to wrap up. Sound good? Yep. Okay, cool. So before we go anywhere, though, I need to get this out of the way. This word sucks. And particularly in the context of design, if you say testing to a designer, they're going to go, oh yeah, user testing, which is great. And user testing is super important, and it's a credit to design that design tends to be the one in the last 10, 15 years who's really been carrying the torch to make sure that we're testing, that we're interviewing, that the user is involved in the process of building product. But when we say testing today, it doesn't only mean traditional user testing. We're also going to need to distinguish between test driving and between just testing in general. So I would ask all of you to be specific in your thinking and in your listening with what we're talking about when we're talking about testing, because they're different and it's a little subtle, but it's important. Okay, so Agile and testing and design and how they play together, right? 20 years ago, there were a lot of problems in development land, and people weren't happy. And many of you guys might be familiar with this website, right? This is the Agile Manifesto. And interestingly, as you start thinking about this, because what we're doing in the design movement, who are trying to adopt Agile, is we've got to reverse engineer it. Nobody really wrote down what problems was Agile trying to solve. But the principles behind the Agile Manifesto, which is kind of the sub-page of the manifesto site, it's got these 12 principles, and you can kind of reverse engineer the principles and the problems that led to the techniques that we now group together and call Agile. We could kind of tease those out. So I wanted to shorten it for you guys because we don't have a lot of time today, so I made it 2 words, which is things are hurting us right now, right? It gets a little more specific. And if you break down those principles, the problems that Agile is trying to solve tend to be around these things, right? So there's, and I'm not going to read them all, but changing requirements led to backlog churn, and you're working on something and the next day you're told to work on another. And seagull management, do you guys know this term? It was like, come, disappear. This is never a healthy or respectful way to be. Poor communication loops, et cetera, et cetera, et cetera. So these are problems that developers faced 20 years ago, and they came together. And the result of this sort of stuff is that the work is not getting done as well as it could be. People aren't happy. Businesses aren't happy. Whether it's a product or consultancy, you're wasting. And what we love about Lean, about the construct of Lean, is that we're striving to eliminate waste and minimize waste, right? So these are some of the ways that you would see these results, right? This lack of trust between the build team, product and design and engineering, and the business unit saying, what are they doing? How come we're not getting farther? The people on the team not being happy, and the product not being able to pivot as quickly as it needs to in order to be effective in a very fast-moving marketplace. And at the end of the day, this is a bad place, and we don't want to be here, right? So designers have this problem too, right? There's nothing that we just saw that doesn't apply often pretty similarly to design. But back to developers, right? They came up with this is the core of the Agile Manifesto, right? And it's these kind of 4 main principles of individuals' interactions over processes and tools, working software over documentation, collaboration over negotiation, et cetera. You guys have seen this stuff, right? And it's not that the thing on the right is totally bad, it's just we prefer the thing on the left. We want to strive for the left. And I think more in development than in design, we see the left values emerging. And one of our jobs right now is to help bring some of that to design as well. So that's a nice statement of values, and it's very fluffy, but day to day, what does that mean we're doing, right? We're breaking it down here in a few different chunks and fidelities, right? So all the time, we talk about outside in development. In the bad old world, there would be some horrible committee somewhere that would throw over the wall a spec at you, and you would be building these features that didn't always make sense, and the specification was made at the point in time where we knew least that we ever will. And outside in inverts that, and it says, let's start with the user, and let's work our way from the user's point of view into what we're doing. We're trying to optimize for low cost of change, right? In the old world, when we're building, engineering comes from bridges and pyramids and, stealth bombers. We're building with atoms and not bits. And the cost of planning and the cost of building are orders of magnitude different. So it makes sense to plan up front. You plan as a distinct phase. And when you're done with your cheaper planning, you have your plan and then you give it over to build, right? Maybe that means design and engineering and testing, whatever. But there's this handoff process. That's Waterfall. And in order for Waterfall to be effective, you need to be predictable. You need to know when you're going to be able to hand off your designs to the engineers so that you can schedule everybody. But that's not the world we live in. We live in a world of digital product. We're building with bits and not atoms. And the fundamental difference is that the cost of planning and the cost of building, order magnitude-wise, are the same. So now we don't want to optimize anymore for predictability. We want to optimize for the low cost of change. We want to not have to be right the first time. We want to just build the MVP, the minimal thing we can build it as quickly, cheaply as we can, put it out in the world, and learn lessons instead of having to hypothesize the lessons. Agile optimizes for tight feedback loops, right? Both within the team, with the users, with the business unit. And this, again, is a change from the days when you'd have a committee making a spec and 3 years later you ship. So day to day, or week to week, I suppose, the weekly cadence, right? We're doing iteration planning meetings every Monday, get the team together and make sure for this week's chunk of work, we know what we're talking about. We use the same words to describe the same things. We have a shared understanding. And that means that any piece of the team can pick up that project. Implementation details can be left to the team that implements them, the pair that implements them, right? We'll also do the more strategic release planning meetings where we say, every week or two or three, how are we doing in the bigger picture? Are we on track for our larger goals? And at the end of the week, we can do a retrospective, and we can get all the team together in a room, we can all open a beer, and we put a smiley face and a frowny face and kind of a meh face, and we throw things on the board, things that are bothering us and things that are going well. And because we're doing it early and often, and we're investing time and energy in continual improvement, people don't get too upset and things don't get to fester and you don't bottle off a lot of steam. We're able to make the process responsive to what's going on the ground. This is very valuable. So on a daily level, what does that look like? How many people here do stand-ups in their day-to-day life? Okay, that's almost the entire audience, right? You spend 5 minutes, you check in with the team. Here's what I'm doing. Here's what I need help with. It's a communication loop. We do pair programming. So we recognize that the biggest cost is not writing code. The biggest cost is maintaining a system. And if we have better code going in, better product going in, then over time, the cost is going to be lower. So let's put 2 people on it. Let's make sure they're talking to each other, that you don't go down rat holes, that your attention doesn't wander off to Facebook, because your pair does not care about your Facebook. And so you find yourself in a world where somebody's saying, no, my pair cares about Facebook. You find yourself in a world where you get to focus and do interesting work and go home at the end of the day and have a life. Test-driven development protects us and protects us as engineers from breaking our system. It helps us do better object design because we're driving it out through tests. And finally, continuous integration is a way to make sure that the whole system is healthy and that we know when it's healthy. We're going to talk about all these things. So the designer's pain, I made some green notes here. These are the only words I had to change here, and I just changed build to design because it's the same thing. It's people building product. And we're seeing the same results for designers. So now things start to get a little different, right? But let's take a look at what we've got. So before we were talking about outside-in development on the engineering side. Well, in design land, we talk about that in the context of user-centered design, human-centered design, design thinking. IDEO has been doing this for 20 years. This is not a new concept, and it's starting to get some traction in the business press, which is phenomenal. But this is actually a story about engineering kind of catching up with design, which is pretty cool. As an analog to lowering that cost of change. One of the expensive things is, for many years, the early years of the web, we're designing web pages, but pages don't make that much sense anymore. Pages was taken from a book metaphor, and we're beyond that metaphor. We're building apps now. So we need to get away from pages and think about systems and building visual representations of our object models. We're building a visual system that's a metaphor, the same way object-oriented software is a metaphor for something in the world that we're mapping onto product. So Brad Frost is doing some pretty cool work around atomic design, and we're starting to see more and more people in the design community talking about and recognizing that our job is to build a design system. As far as short feedback loops go, again, design has been way ahead for years, right? We've been carrying the torch for user testing before anybody else. So these continuous values are very well entrenched in design land. On a weekly level, we're starting to see a lot more kind of story-centered design. Google Ventures is doing some really cool work with this, building out design backlogs and taking design away from this idea that the designer is a mythical, magical unicorn who gets a brief, goes off to an ivory tower for 2 weeks, comes back like Don Draper and kind of unveils what he's come up with. That was great in 1950, but it doesn't work that well for building apps. And as we start talking about it more, we start to qualify and quantify our work in ways that are more granular. And we don't have to deal with this, it's either completely done or completely not Don Draper thing, but we're able instead to work more in concert with agile engineering. On the strategic level, the release planning, we've been talking about big design refactor and this recognition that engineering and product are moving at this weekly cadence where every week you're going to add a feature, take a feature away, add a feature, add a feature. So there's this weekly cadence for product and engineering, but for design, for formal design concerns, it's not like that. You're building a design system. So if we're adding a feature, taking a feature away, adding a feature, all of a sudden our horizontal navigation, we ran out of room. We have too many features now. So okay, we shift over to a vertical navigation. We've got enough room. Okay, that's good so far. And for engineering, for product, doesn't really matter. But for design, who has a responsibility to make sure the design system, the layout is intuitive, those things work, all of a sudden you've got to move your entire layout. You've added this new column, and it's a lot more work. So what we've learned is that if you have these little loops where they're adding and taking away, you don't want to be shifting from a horizontal to vertical, back to horizontal, back to vertical. You can't do this. And when designers try to take this big loop and squish it down here, they get really, really pissed off. It's too much work to try to squeeze into that. So the solution is to recognize that it's a different rhythm and to communicate with the team. And as the designer, you have the vision, you have the facility to, when you get about here, say to the team, hey guys, we're okay right now, but like in a week or two, this design system is going to be completely broken. And I'm going to need a week where I'm not tending to the backlog, I'm not generating assets. So if you guys have a big technical refactor, that would be a great time to like clean up some of that old code, and I'm going to get to step back and kind of refactor the design system, and understanding that that's the rhythm and that's the cadence of how design systems integrate with agile engineering helps designers not feel squished and told that they are going to get to try it again and iterate continually, but in reality be forced to play catch up the whole time with a bigger team who moves faster. Other things, retros, yes, we're doing them. Stand-ups, we're doing them for design. At Pivotal, we were doing daily design stand-ups, which was great. 5 minutes before lunch, I'd play my ukulele, this is where it came in from the bio, and everybody around the office would follow me. All the designers would follow me. We'd stand in a circle, 20 people, product and design, and we'd do a quick stand-up. What are you working on? Do you need help with anything? And it was a wonderful way of learning what other people are good at, learning what people are working on, understanding the state of the office, and maintaining team cohesion. We've started doing design pairing. So the same way engineers will take 2 keyboards and plug them into one machine and use a text editor and a terminal and a web browser together. We'll take 2 keyboards and 2 mice and plug them into one machine and be an illustrator together, a sketch together, and use that to talk about what should this design system look like? Are we modeling this correctly? Is this the right metaphor? Oh, hold on, I have another idea. Let me try this. And when you have 2 designers who can work at speed in Illustrator, it's really, really wonderful. As a designer, it's very freeing to be able to speak fluently with a peer. So there's a meetup the other day. We talked a little bit about this. There's more talks about this. If you're interested, you can find them or come talk to me. Okay, so the things that I really want to address in this talk are TDD and CI, maybe a little in this talk, probably the next talk that comes, right? But these are the very critical day-to-day things that we need to do as designers and as a design community in order to start taking advantage of some of the learnings that the engineering community has had. And this is where we're going to not adapt it one-to-one, but try to find ways that we can do it. How you guys doing? You look very like post-lunch. Like, all right, well, settle in, just listen to me talk a lot. It'll be fun, I promise. Okay, so theory. I want you each to read out loud everyone. No. So yeah, there are, and I'm not going to read all this stuff, but design is such a sloppy word. When I say I'm a designer, people go, oh, did you design that shirt? And I go, no. Did you hang that wallpaper? I go, no. And we have to start talking about, well, there's visual design and front-end engineering and tactical UI and strategic UX. And it makes it hard to have this conversation until we have a common language around what exactly we're talking about. But there are all of these problems against those 4 verticals and many others that need to be addressed in order for us to build effective product, right? So the question is, what can we take from testing in order to help? And I'll assert a few things. Number 1, automatic testing, not the user testing we used to do, but automatic testing can help us with convention over configuration. It can help us separate the interesting problems from either the trivial ones or the ones we've already solved, but we're still spending time and energy trying to make sure that they stay solved and we didn't accidentally break them. The other thing that we can do, and the other thing that I think TestDriven particularly offers, is a definition of done. Designers, I think more than engineers, face clients, stakeholders, whoever, who may have a superficial understanding of design, but don't understand what's going on deep beneath it. That often leads to scope creep. It leads to people saying, oh, make the logo bigger. And it's not healthy. And I'm suggesting that if we do a better job of defining done for design, it will help everybody move more quickly, be happier, be healthier. Okay, so what is TDD? What is test-driven development? Back in the day, in Waterfall land, you would have an engineering team, and they'd write features according to some spec that came from on high, and then there's a separate QA team, and they would retroactively poke at the app and then try to write automated tests against it. And it was an okay idea, and there was some notion of kind of separation of powers, make sure that QA is checking dev and dev is checking QA. It was a very adversarial relationship. And then around the end of the 20th century and beginning of the 21st, you started seeing what became the seeds of the Agile movement come, a lot of it in the Smalltalk community. And the book Extreme Programming Explained was published. It's a phenomenal book. It talks a lot, whether or not you're an engineer, about what it means to build product and what it means to take something in the world that people need and figure out how to do it in software. And it's a good read. I highly recommend it. And Agile tends to mean extreme programming and Crystal and Scrum and a handful of different methodologies all got lumped in as Agile after that Agile Manifesto summit that we saw slides of earlier. So Agile inverted that model, and it said we're going to write tests first, and then we're going to write the features. And by the way, it's going to be developers writing all of them. So QA departments start to either disappear or do something else. They start to do exploratory testing, which is a whole other topic. But if you're interested in it, Elizabeth Hendrickson has a phenomenal book called Explore It, and I highly recommend it. So Kent Beck, who was one of the early leaders of the Agile movement, kind of rediscovered TDD. It turns out that way back in the day, like in the 50s, when you 8 computers on Earth and you got to go to MIT because you're a professor there and batch process at 3 in the morning, you get 20 minutes of compute time. Because their computing time was so valuable, they would often do testing first. They would have some trivial data case, they would solve it by hand, they would just run that first quick thing, and they would see if it's green, they'd run the whole batch, but if it's red, they didn't want to burn their batch time. So this is actually a very old technique, but it was dormant for many years until it was kind of rediscovered around the turn of the century. So to kind of talk a little bit about test driving and really illustrate exactly what it is, we're going to do an example. This is my favorite website. It's Hamazon.com, your fine pork purveyors since 2010. I'm imagining that you all can imagine what an e-commerce site looks like for pork, right? You've got your various pork products, and our users here are the buyers are people who love pork, and the sellers are pork farmers and maybe distributors. And you can kind of figure out what's going to go on here. And so today you and I are going to pair. Right? So we're going to do ping pong pairing. We're going to, I write the test, you make it pass, and the next story you'll write the test and I'll make it pass. So here's our story. Users should be able to add item to shopping cart, right? It's kind of early building out the e-commerce. We've got some things built, but we're probably not at MVP yet. So we're going to use a testing technology called gherkin. And gherkin is a DSL, it's a domain-specific language, so it's using a lot of plain English to do things that the computer can read. And the only thing you need to know about it right now is that it's got a few magic words, right? Given, when, and then. So what we're going to do is we're going to have our story. Can you guys see that? Yeah, that's pretty big. That's really pretty big. So given I'm a logged in user, when I go to the item page and I tap the Add Item to Cart button, then I should see the cart inventory increment, I should see the cart subtotal increment, and I should see the warehouse inventory decrement. This is a meaningful story. It's the smallest unit of work that has user-facing value. The non-technical PM can understand it, and the computer can read the thing, right? So here are the rules for testing. That's a readable piece of software that you just saw, and we're going to let each line pass or fail, go red or green individually, right? So the whole kind of big picture, we call it RedGreen Refactor. We're going to write the red failing test, we're going to make it pass, and then we'll refactor it. If we see, oh, you know what, when we did this, it's kind of like this thing we did over there, let's extract them both. Or if we see, hey, we used to have a seller model and a buyer model, but it turns out they're both people, and there's a lot of common stuff, so maybe we'll make a new model called people, and they both subclass, blah, 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 right? But we're reinterpreting our metaphor of the object domain out in the world to the software that we're building, and that's refactoring. Okay, so we're going to write the red test first, right? It says, given a logged in user, when I go to the item page and I tap, right? So we'll say we already wrote login. That was another story, it was done, okay. And we'll say that we already wrote the item page. So given them a logged in user, that's green. When I go to the item page, green. And I tap the Add Item to Cart button, that's going to go red. So I just wrote that test, it's your job to make it pass. Okay? So what are you going to do? Pretend we're in Ruby on Rails because that's what I'm familiar with. We'll go into the part of the code base that's got our HTML views. We're going to find that item page, and we're going to add an HTML button element. That's all we're going to do. It says Add Item to Cart. That's it. That's it. No database, no nothing. We're just trying to make the test pass line by line. So we run it again. So given them a logged in user, good. When I go to the item page, good. And I tap Add Item to Cart, good. That one passes now. So the next one fails. Then I should see the cart inventory increment. Great. Now it's time to take that button, connect it to the database, do all the business logic and all the engineering that we're going to need to do. We'll see that cart inventory increment, and we'll run the test again. And we're just going to keep doing it, right? Now we're green on see cart inventory increment, and we'll see the cart subtotal increment. So now we need to go into the, maybe write a method for subtotal, blah, 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 and that goes green, and then we go again. We say, okay, we want the warehouse inventory to decrement. Great. And now we're done. And done means done means done. This is done. We might refactor a little, blah, 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 but we have a meaningful way of talking about this work is done. But now we're going to run suite, right? We've got a test suite. Because remember we said, hey, pretend we already wrote the login system and pretend that we already have that page. Well, there are tests around those too. So now we have a chance to see if our new software broke the existing app that we've got. So we're going to run that. This is a great time to kind of like get up and stretch and maybe play a game of ping pong. It'll take a couple minutes, no big deal. And you come back and, oh shit, we broke suite. Right? The whole test suite broke. There's something broken. If you were to deploy this software into the world now, it would break and it would not be good. And this is kind of interesting and important. We know this now. This is time travel. This is magic. Because in the old world, in the bad way, you wouldn't figure this out until 2 weeks from now. You broke the warehouse code. Wally in the warehouse, he's got a clipboard and the shells and they don't match up. And he doesn't know why. And it's very expensive to fix it. Now, you know what you're doing. You know what part of the code you're touching. It's a lot cheaper to solve problems. So, here's our chance to refactor. We'll write tests if we need to, blah, blah, blah. We go green, we push. Good? Good. Right? And now we are getting away from this very reckless notion and getting more towards a notion that technical risk is something to be mitigated, and we can abstract deployment decisions away from technology. And we can say to the business unit, you're not going to have these weird guys in the corner who do something you know nothing about breaking your business. So I don't want to go too deep on this, but it's going to become important later. There's more than one type of test. So in the gherkin, we talked about the outside-in testing. As we drive through it, as we pick up a particular method, that'll be another type of test. We'll probably do a unit test. And the important thing to take away from here is that these different tests represent checks on different parts of the system, different levels of resolution, and they relate to each other. So you might have a gherkin test drive into a integration test, which will then drive into a unit test. And this is going to be important for us later when we try to put together a testing pyramid. The testing pyramid is a metaphor, is a tool that we use to say, well, for every 100 unit tests, we want 10 integration tests for 1 unit. We want to make sure that we've got a healthy ratio so the tests are fast and don't break too easily. We want to keep cost of change low. Okay, so the benefits here, right? Anybody can read this stuff. There's no secrets. There's no difference on the team between the people who know what we're building and who don't. We're not over-engineering because we're just stopping at making the test pass. And again, we're starting to get away from scope creep. Okay, so we did definition of done, RedGreen Refactor. You guys mostly know this stuff. I'm going to try to speed it up. Okay, so this, to me, is the interesting part. Like, how do we take that? How do we map that to design? There are a lot of people who are working on automated testing. There's a site called css.test, css.test, and they describe it as these different techniques. At the end of the day, there's a few different things that they're really doing, right? So screenshot diffing, this one on the left over here, this is right. So imagine you've got the kind of before photo or screenshot and the after screenshot, and you superimpose them and you do a diff, and you can set a tolerance, right? You can say if it's not 100% perfect, then it fails, go red, send a human in there to go fix it. Or maybe you say, you know what, we changed the copy, so we know that if it's, as long as it's 5% the same, we're probably okay, so don't make it go red until there. So this is letting us test against regressions, it's letting us see what's going on. Imagine when you have one of those websites where you've got like 20,000 lines of CSS and it's just a mess and it's been a mess for years. Imagine if you had automated screen diff testing where you could say, I know what it's supposed to look like, I can muck around with the CSS all I like, and as long as the result is the same, I know I'm good, I know I can cut those 20,000 lines of CSS down to 5,000. That can be kind of fun. This one over here is a different UI essentially, so each one of those green boxes is a test and then they're passing. This is a red test, so you can see that the button moved from the left to the right. And this is either a design decision that you want to go and bless the new one and say, we'll compare all future ones against this, or you want to say, oop, we broke something we didn't mean to, let's go in and fix it. There's also an idea to unit test CSS. This is a little interesting, right? You'll recognize this is gherkin, right? Like given I visit, then blah, blah, blah. But we're talking about design decisions in a very granular manner. There's a few tools out here who are doing this. It seems as if a lot of work is being done in this area because it's low-hanging fruit, it's easy to test, and that's very important. The places where it becomes useful and meaningful is another story, and we'll talk about that in a bit. Linting is also an area where there's a lot of work done, again, because it's kind of easy. You do static analysis on your code, and then your text editor or command line utility or whatever says, you put the semicolon in the wrong place. Or at this company, our code convention is that you do, 4 spaces for a tab, not 2. So make sure that you are writing code consistent to our code style, not the style guide for the visual design, but our code style guide, so that anybody who looks at this code is looking at the same thing. They know what they're seeing. You're not getting these style differences confusing you. So, okay, this is kind of meaningful stuff. But But, oops, something is missing though. And what's missing is that we're testing CSS, we're not testing design. And if we're going to go anywhere with this, we need to test design, not just the implementation of the design. So here's where we start talking about what can we actually do, right? What is the methodology, not just the theory, but the methodology for doing this stuff? If we took it super literally, we could try to use that technology to test drive, right? We could imagine using that image diff. Well, we'll have the designer make a Photoshop mockup and export as a ping, and then we'll just take screenshots until we get to green. And okay, that's maybe going to make sure that the implementation matches what was intended. And if you're using Illustrator and the drop shadows don't render the same way CSS drop, okay, but it's probably not the best ROI. There are places where it might be more valuable. Responsive is one. Style guide-driven design is a really interesting idea where you can take a live style guide that is showing what each component ought to be, and then you're testing it across the site and making sure that you're complying, making sure that if you have a shopping cart widget in the corner and a new developer is implementing it, they're implementing it the blessed way where the styling rules apply and not making up their own. So there's some projects, we'll talk about them in a minute, like StyleCop, that try to do style guide-driven compliance. The unit testing, again, writing those tests is tedious, man. Like CSS is declarative. You are saying like this paragraph should be this color, so why do it again in a test? Regressions are a good place to do it. I've done this where you start breaking things, and every time something breaks because of usually unintended cascade, you wrap it in a test, and it starts to make life a little bit better. But again, we're just trying to find something that we can hook into CI and start building a rough, shallow framework around design. Yeah, and for linting, I don't even know. But let's get away from the technology for a second. Let's just think about that technique, right, of setting up acceptance criteria up front for design and then doing it. I came across this quote in researching this talk, which I really liked, right? Process changes are much more profound than the technology that enables them. So we talked about those different types of design. What might a TDD approach look like across those different types? So we already talked about a bunch about front-end engineering, so I'm not going to do that one. And many people may do this anyway, but starting to give it a name and understand that it exists in this continuum of ways to test can be valuable, right? So for a long time, you can take, as a team, you've come together, you've made those gherkin tests, right? You understand what's going to happen. Let each line be a title of a mockup. And let that be a way that you as a designer, when you're working through user flows, you make sure you've got total coverage, you make sure everything corresponds, and you start to take a test-driven approach to some of the more fuzzy visual design. On the UI side, we talked a minute ago about live style guides and compliance. So as you build the style library, you want to make sure that A, it's being used, and B, it makes sense. And one of the really interesting things we found, we did this a few years ago on a project which was very big, and pretty quickly what happened is you had like 17 different sign-in forms, 8 different sidebars, 22 different alert boxes, and semantically they weren't any different. Maybe there's 3 alert boxes. There's regular, guest, and like holy shit, hair on fire, alert, alert, alert. But if you've got 22 different implementations of it, you're not doing anybody any favors. So the first thing they did was create a new route that said /style guide, and every time somebody saw one of those alert boxes, they just dump the DOM in there. And after a month, we had all 22 in there, and we could sit down for 2 hours with a designer and a PM and say, what's important here? How many do, we need 3? Okay, which are what are your 3 favorite? What's your favorite guest, your favorite normal, and your favorite emergency? We picked them and blessed them. And then every time developers came across one of the ones that wasn't blessed, they'd convert it. And pretty soon you had a fully styled, consistently implemented code base. And the cool thing was developers could start rejecting stories in IPM. They could start to say, if the PM would have this new feature, but we didn't have interface for it, they'd say, you can't do that. I want a 1-point story for building it out in the style guide first, and then from then on, you get that widget for free, but we need to make sure that it's checked into the system and it's part of our design system. And this helps with some of that design system coherence we were talking about earlier. On the UX side, we experimented with something called persona.yaml. So designers will build personas of the different user types that we're going to have, right? We've got Billy the buyer and Sally the seller. And engineers are going to be writing tests all day, but oddly, the most common protagonist in a test is Homer Simpson, right? You've got 2 engineers sitting next to each other trying to make the guy next to him laugh, and you start to lose a lot of good work that's been done on who are these users. So persona.yaml would make a test fail and make your CI go red if you had personas, you describe them in that YAML file, you had personas, but they weren't being used in the test, or somebody else is being used in the test. This can flag it, and it can pull together the work that design is doing with the work that engineering does, but doesn't always sync right up. There are also tools out there like usertesting.com and Ethnio where you can do the more traditional type of user testing testing that is what many designers think of when they think of testing in a somewhat automated fashion, right? It's got an API. So there isn't a ton of work that I've seen that is automated testing with these two, but there's certainly the seeds of it there. Finally, lean hypotheses, which we kind of talked about earlier, are a way of setting up your acceptance criteria, saying we believe that blah type of user has blah type of problem, we'll solve it with blah type of solution, and we'll know we're right if blah type of key performance indicator changes. You've set up your acceptance criteria, and now your MVP or your design story is the least amount of work you can do to validate or invalidate that hypothesis. So the technology doesn't really correspond, but the practice and the theory does. So all of this is leading us to a place. We talked about the Amazon example where you've got that CI build. You know whether your software is healthy or not. And to do that for design gives great benefits, because right now we tend not to have an agreement among a team on whether the design is healthy or not. And that makes it really hard to prioritize whether we should be polishing up things or it's not worth polishing them, work on epics a couple weeks down the line, or work on mocking up next time. If you can abstract away some of that stuff and have us just all agree that if that square goes red, we need to go and fix it, it makes life a lot better. A question that I would suggest helps us figure this out is when we're going from testing to test driving, can we plug this into CI? What would it sound like to plug this into CI? So we talked about that big design refactor before, and we talked about those small iterations. Maybe the big design refactor plugs into CI by saying, well, if I've got stories in the backlog that have a design needed tag on them, I need to put design either on the mock or the asset. It means I'm not thinking far ahead. So we know what part of the cadence we're in. And these things are sloppy, but the idea is we got to start doing it so we can start refining what the right key performance indicators are so we can know when we're healthy and know when we're not. This is kind of what we just talked about. So the kind of upshot of all of this is a pyramid scheme, right? The testing pyramid, as I started to allude to earlier, describes different types of tests and the proportion in which they ought to go to each other. And the reason that I hope it can be useful here is just the notion of how different types of tests and different levels of resolution of testing correspond to each other, right? So kind of the simple version for development is for every one acceptance test, which is that high-level happy path, given a logged-in user, when I go to the blah, 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 and you're running it through Selenium or something like that, it's a slow test. The computer is actually clicking on each link, and you can sit there and watch it. It looks like a spooky ghost is doing things. There's one of those. There's 10 integration tests, so you're checking whether the warehouse software is this warehouse service is talking correctly to the shopping cart service. And then there's unit tests, right? Each individual method, like increment inventory, decrement inventory, whatever. You're just checking those work. These are very fast. These names aren't always agreed on. If you go back to this slide, this is just a Google image search, and you'll see they don't quite match up, but they're meaningfully, conceptually talking about the right thing. Okay, so here's kind of the main event. And I'm not going to go through all of these, but what I hope this slide illustrates is that in all these different types of things that we're talking about, right? The problem we're trying to solve, the technology we're using, certain kind of overarching strategies that we'll do to do it, who it applies to. Are we doing it every time we have a persona, of which there's generally single digits on a project? What about responsive? How many viewports are we dealing with? Often it's around 60, 70. Starting to understand where these things live, which ones can be easily automated, checked off the list, and we'll never have to think about again, I believe is going to be the beginning of us being able to have a conversation around what we've got so far, what we need. There's a few in there that say build me. So if anybody's excited about this stuff and wants to work on it, there's a lot of really good, interesting open source work out there to be done. So that's really pretty much what I've got. I think the imperatives here are we as a community have started on this path. We need to continue. It's going to make us happier and healthier. We can look to engineering to see what it's done for them. A lot of this is not just about building technology, but also socializing ideas and helping designers have a common language around what does it mean to be healthy and not be healthy. And finally, think not just about the tooling, but also about the practice, and make sure that even though it's important and we have to build, these tools are necessary, and it's really important work that's being done, but they're not sufficient. We need to be able to tell a story as a community about how these things fit together in our workflow and why our clients and our products and our projects and companies ought to invest time and energy into it. So a few kind of quick takeaways. Agile is for design. And when designers get scared of Agile, it's important to step back, ask why, and figure out where we can apply it. Automation is really key. Testing is a sloppy word. and it's important to test the design, the unit of decision, and I'm excited about what's ahead. So that's what I've got today. Thank you guys so much for listening, and I hope you enjoyed it. I've got a bunch of resources as well for anybody who wants. Thank you very much. Do we have time for Q&A?
Around 7 minutes, so...
Okay, we have 7 minutes for Q&A.
I've got one, but I wonder if somebody would like to start. Okay, I love the example that you mentioned about the comparison between building software and bridges and other stuff like that, that people stick to thinking about building software in the way that people prepare buildings 2,000 years ago. But my question is very, very general compared to your presentation, that do you think, as a whole, as everybody here, do we develop ourselves? Because I feel that 10 years ago, there were different buzzwords. Maybe not Agile was not so, you know, but everybody hates already Waterfall, pardon. And do we develop ourselves? Do you feel that this has changed over the years?
Do you mean are different members of the team engaging in development and engineering?
Maybe other words. I feel that each team right now, even in the 10 years starting from now, will just start with Waterfall. It is somehow in our DNA or something. And you just could use this presentation in 2025, etc.
Yeah. I understand the question, thank you. And the question is there progress? Is Waterfall just a part of human nature? I would say no. And there's a wonderful quote by, oh man, who wrote, I'm completely blanking. It's like my favorite quote in the world. Bill Gibson, right? He says, the future's already here, it's not evenly distributed. Right? So we are learning about better ways to build things. And short feedback loops are really the name of the game. And the difference between Waterfall and Agile is that the feedback loops are shorter in Agile. So not everybody knows about it yet. Not everybody's heard the good news. That's why we do conferences like this, right? We're spreading the gospel. But the important thing is that we are finding a way for teams to work together in a healthy and human way that leads into all of our strengths, makes people happy, makes products happy, makes businesses happy, and I would argue that shorter feedback loops are a fundamental piece and a fundamental heuristic to figure out, is our process working? How is it that we're building amazing things? Does that answer your question?
Yes, I hope so. I mean, I hope you're right. Let's say,
Me too.
Let's say it this way.
Yeah, well, if not, it's been a fun ride.
There may be a very specific question. I mean, sprint time. Sorry, it's not covered by the presentation, but you know, there's guys who say 3 weeks, others say 1 week. We are talking about design process, and I'm wondering if it fits my findings.
Sure.
So what would you suggest?
I think smaller is better. Week-long sprints have always been very effective in my experience. As I was describing before with the big design refactor, and sprint is a little bit of a loaded word because in Scrum it means one thing, but whatever. It's the unit of time and the unit of fidelity. The most important thing is communication, is that the team is sharing their idea of what the unit of time is. So I believe that there is a fundamental difference between these weekly product and engineering sprints and the longer big design refactor sprint. So it's important that the team communicates about that. But whether this is, you know, a month or 3 months, it probably depends on the project, and it may change over time, and it may depend on the phase of the project. But it's that level of resolution. It's probably a couple months, maybe a couple quarters.
Yeah, you just say weekly and once 1 month or 3. So this is the answer, I think.
Weekly for engineering and product, 1 month or 3 for design. But again, it depends.
Yeah.
I'm a consultant. I always have to say it depends. It's in my contract.
We've got 3 minutes left if somebody would like to raise a question.
Hi. It's difficult to say what is a design. Yes, you can get screenshots or get a lot of things. But one thing that for developers is really useful is when you have automatically created assets, images that just go to the design. So I think that one thing that could be useful on the building process is that the design is on the Git repository and all assets are generated from them. If something is missing, then the build fail. But the implementation is easy. Yes, you have CSS, for example, and then you can check that. But it's like, how do you test architecture of a service when these are just graphs? So it's difficult. So what we can do to get more technical result from the designers. I think that this
That's
is
a
a
great
good question. So assets, automatic assets is one thing that I think, but I don't know what else we
Sure, I
could get.
think the first thing we can do, and I've given a lot of talks on things called things like Git for designers, right? It's about communication on a team, and it's about pairing and learning and trust and collective ownership of the product. So the more you can do to pair with the designer, the more open they're going to be to learning how to get technical and to learning how to script out of Sketch so it's automatically generating assets. You're absolutely right. The more boring stuff we can automate, like generating a bazillion different assets for Android because they've got so many screen sizes, nobody wants to sit there and do that work. Computers are really good at that work, but many designers may be scared of the technical acumen that's required. So the first thing that you can do as an engineer is be welcoming to designers, make time to pair with them. A lot of people I know, they'll do pairing Fridays. So after lunch, Friday, it's kind of quiet anyway, you sit down with the designer and developer next to each other. They're going to learn, hopefully the designer has their fingers on the keyboard and you're kind of coaching. This is the classic pairing as continuous code review, where the senior person is kind of coaching the junior person, right? And what you're doing is you're helping them understand CSS, you're helping them understand, a mobile framework or something like that. And you're starting to learn design things that you didn't know. You've been pushing pixels and margin and padding for years, but do you have a sophisticated understanding of typographical hierarchy or rhythm? Often the answer is no for developers. And to start to get that, it doesn't mean you're going to go be a designer the next day or that you'd want to, but it does mean that the next time you've got your own project or the next time you're not sure about something and you can't find the designer to ask them, you've got a more conceptual, sophisticated understanding of fundamentals of graphic design. So this cross-functional pairing, interdisciplinary pairing, becomes a really nice way to learn things you wouldn't otherwise and to build cohesion among the team. So that's one place I would start.
I've got one more question regarding the list of tools. I mean, there's a to build me. Is it true that there is a real lack of tools for automated tests, especially UI tests for mobile? I mean, major one. That's why really grow up, and you could just get it in use.
I'm
talking about mobile apps, not.
Yeah, I mean, mobile, I think in general, and I might be totally wrong and crucified for this, but my understanding is that the tooling ecosystem in mobile is less sophisticated and evolved than in desktop, just because it's been around longer and there's been more time for this stuff to grow. If you go to Ruby on Rails, for instance, you'll find very sophisticated tool chains and then less so for, say, iOS development or Android development. The ones that say build me, these are story-centered design CI. What would that look like? What would it look like to throw a red build, to have a failing test if our design work wasn't captured in stories? Well, maybe you're just looking at your backlog and making sure at least one story has a design label on it. That's a place to start. And then you work on your team like, man, we keep throwing red. This is not true. It should be at least one every 2 weeks or whatever. But the point is, as we start these things, we will develop more sophisticated understanding of what helps and what doesn't. But we're lacking infrastructure right now. And these are not technically particularly complicated. These are technically, you're looking at a list, you're searching for something, and you're returning a binary. So I'm hopeful that as people coalesce around testing as a theory and methodology, that the tooling follows and the practice follows, and we all live happily ever after.
Hope so also.
All right, I'm out of time. Thank you guys so much.
Thank you very much, Jonathan.